Alrighty, in this video we are going to talk about oxidation numbers. And oxidation numbers are something that we use to show what the general distribution of the electrons are in any of our bonded atoms or in our molecular compounds. So this kind of gives us an idea of where the electrons are in our polyatomic ions. It's as if you were to make charges for molecules. All right, and these oxidation numbers are going to follow a series of rules. All right, so let's go over the rules and then we'll go over some examples. All right, so since we're talking about the distribution of electrons and seeing which ones are going to have more or less, anything that is pure or uncombined has an oxidation number of 0. So if you have just the element sodium, that would be 0, or a diatomic molecule of oxygen, 0, or sometimes phosphorus makes these conglomerates of 4 or sulfur of 8. They are all 0. Okay, all of the charges in your formula must add up to 0. So that doesn't matter if it's ionic or if it's covalent. Remember, we always have neutral compounds. So that is a very big, important thing. Okay, as for the rest of the rules, they are going to talk about what the specific charges are. So everybody in group 1A, your alkali metals, group 1, they're all 1+, just like we know in set 1 of our common ion sheet. All group 2 alkali earth metals are all 2+, like we know of set 2 in our common ion sheet. Okay, rule number 5 is a biggie because we're talking about fluorine. Fluorine is the most electronegative element. So in compounds, it will always and forever have a charge of -1. Okay, fluorine will always be a 1- oxidation number. Okay, hydrogen is another very common example, common element. Okay, it will almost always be a 1+, except for hydrides where it is a 1-. So this is what we saw in set 1, and this is what we saw in set 4 of our common ion sheet. Another big common element is oxygen. It will almost always be a 2-. Okay, except for if we're talking about peroxide, which is O2, 2-. Remember him from set 6 of our common ion sheet. If you were to divide up all of the charges for each of your oxygens, it would be a 2- charge divided by 2. 2- divided by 2, so that would mean a 1- charge. And if oxygen is bonded to fluorine, fluorine's rule supersedes that. So in a compound called OF2, it would be a 2- because oxygen and fluorine have to equal 0. Okay, so if you have 2 1-, oxygen has to be a 2+. So where you're going to spend most of your time is going to be when we're talking about our polyatomic ions. All right, in our polyatomic ions, the charges have to add up to the ion's net charge. So all of your oxidation numbers have to add up to that charge is. So you have to look at what you have going on here. So you can approach the oxidation numbers for magnesium, sulfur, and oxygen and magnesium sulfate a couple of different ways. Okay, Mg is in column 2, so that is a 2+. Okay, SO4 has to cancel it out, so that means the total charge of sulfate is 2-. You either figure that out from Mg or know it from our let's see, that is set 6 of our common ion sheet. And then you can assign what the oxidation numbers are for each individual element in sulfate. Okay, so do we have any rules for any of these? Yeah, we have a rule for oxygen. So oxygen is always a 2-, so we're going to use that. And I have 4 of them. So 2- times 4 means that I have an 8- charge. Okay? Now, if you remember, the total charge of your ion is a 2-. So what then is going to be our difference here. Okay, what does sulfur have to be in order to cancel that out? 8 minus a 2 minus is going to be a 6 plus. So sulfur here would be a 6 plus. Okay, you have to get your ions to get the correct charge from the oxidation numbers. All right, so let's take a look at several of these examples. All right, so you should definitely get out your periodic table if you don't have that out already. It's your best friend. It's obviously with you all the time. All right, and then you find what the oxidation numbers are for each of your elements here. All right, so first we have KCl. All right, K is in column 1, so that means K is a 1 plus. Cl is going to cancel out, so Cl is going to be a 1 minus. Easy peasy. All right, NaClO. Okay, this is sodium hypochlorite. So sodium is in column 1, so that is a 1 plus. That means that hypochlorite is going to be a 1 minus. So what are our individual charges going to be, or oxidation numbers going to be for each one? So we have a rule for oxygen, so that is a 2 minus. So if I have a 2 minus, and I am going to subtract the 1 minus overall total charge, that means that Cl is going to have to be a 1 plus. Okay? So you have to split them up. Each and every element gets their own oxidation number. Right, HF, hydrofluoric acid. H is a 1 plus, we have a rule for him. Fluorine is a 1 minus, we have a rule for him. And that stays the way that it is. Okay, ZNO. Okay, I don't have a rule for zinc, but I do have a rule for oxygen. Oxygen is a 2 minus, so therefore zinc has to be a 2 plus oxidation number. Tungsten chromate. Okay, so what is tungsten chromate going to be? I know the charge on chromate. Chromate is a 2 minus. So tungsten has to be a 2 plus. So this is tungsten 2 chromate. Now we go in and we add our oxidation numbers for chromium and for oxygen. So we can split them up. Oxygen's always a 2 minus. 2 minus times 4 means I have an 8 minus charge for our oxygens. We're going to subtract out that overall 2 minus charge. So chromium is going to be 6. Okay, so tungsten is a 2 plus, chromium is a 6 plus, oxygen is a 2 minus. That way you get a 2 minus and a 2 plus charge that are going to cancel each other out. Okay, what about sulfuric acid? Right, H2SO4. H we know is a 1 plus. SO4 has to be a total 2 minus charge. So what are our charges going to be? Okay, let's do this. Oxygen has a 2 minus charge. So 2 minus times 4 gives us an 8 minus charge. And then I'm going to subtract out the overall charge of the 2 minus, meaning that sulfur is a 6 plus oxidation. Okay? NH4 taken twice, SO3. This is ammonium sulfite. Okay? So sulfite has a 2 minus charge. Ammonium has a 1 plus charge. That's why there are 2 of them to cancel out the sulfites. Again, you need to know your ions. So what is our charge going to be for ammonium? Okay, so we have NH4 plus. We will rule out hydrogen. Hydrogen is a 1 plus. I have 4 of them. So 1 plus times 4 gives me a 4 plus. It is an overall 1 plus charge. So that means that nitrogen has to be a 3 minus to cancel that. Okay, and then for sulfite, I have a rule for oxygen. That is a 2 minus. So 2 minus times 3 of them means I have a 6 minus charge. I'm going to subtract out my overall 2 minus charge, meaning that sulfur is going to be a 4. Okay, so I know it's a little packed in here, but nitrogen is going to be a 3 minus, hydrogen is going to be a 1 plus, sulfur is going to be a 4 plus, and oxygen is going to be a 2 minus. All of that is for our ammonium sulfate. Okay, now we have gold and permanganate. Okay, permanganate is a 1 minus charge, so this is gold 1 plus. Okay, then we're going to take oxygen, which is a 2 minus. 2 minus times 4 of them is going to be an 8 minus charge. Subtract our overall 1 charge, 1 minus charge, meaning that manganese is going to be 7 plus. Good. Now we have our OF2, oxygen difluoride. Fluorine is a 1 minus. I have 2 of them, so oxygen here has to be a 2 plus. This is the only time that oxygen loses out. Okay, it is superseded in charge by your fluoride. And then we have Mg3PO4 taking place. This is magnesium phosphate. Okay, magnesium is in column 2, so this is a 2 plus. Phosphate is a 3 minus. You can get that from uncrisscrossing it, or knowing it from Nick the Crafty Camel. And then we figure out our oxygen. Oxygen is 2 minus. There are 4 of them. So that means 8 minus charge for oxygen. Subtract your 3 minus overall, meaning that phosphorus has to be a 5. Okay, so on our next line, we have all of our answers here. If you need to push pause and try them out on your own and see if you're getting all of those, please make sure that you do so. Okay. Lastly, I want to show you where to check your numbers on your periodic tables. Okay, so on the ones that I hand out in class, if you take a look at the key that's in the lower left-hand corner, okay, the oxidation states are going to be those little numbers that are right up here. And if you take a closer look at like nitrogen, you'll see that there are plus minuses 3, 5, 4, and 2. You'll see that the bold ones are the most common ones. Oxygen is a -2, a -1. Obviously, they don't even put that 2 plus in there because it's so uncommon. For fluorine, there's only a 1 minus. Notice there's none for neon and argon because they don't make any bonds. And then you have your phosphorus, your positive, negative 3, 5, 4. Sulfur is going to be 6, 2, and 4, and chlorine is 1, 7, 5, and 3. So you can see that our oxidation states definitely help us with assigning our electron values. And that is oxidation numbers.